Here's problem 33. A wire carries a current of 20 amps along the x-axis from x equal minus 3 centimeters to x equal plus 3 centimeters. Determine the magnitude of the resulting magnetic field at the point y equal 4 centimeters on the y-axis. Let's see if we can graph this. So we have a wire extending from x equal minus 3 to x equal plus 3 centimeters. And then we have a point on the y-axis at y equal 4 centimeters. And we want to find the magnetic field at this point. Our current is going to the right from x equal minus 3 to x equal plus 3. So by the right-hand rule, if I were to point my thumb in the direction of that current, I would have a magnetic field that, at least in the vicinity of point P, would be coming out of the page towards you. Everything below this wire would be going into the page, away from you, but we want to know what it is at point P. So it's coming out of the page towards you in terms of the right-hand rule, because it's kind of just coming around like that around this wire. Okay. Now the magnitude will be given by the Biot-Savart law. So the magnitude of the magnetic field at point P will be equal to mu naught I over 4 pi r times cosine theta 1 minus cosine theta 2, where theta 1 and theta 2 are the lead angles respectively. So if I'm looking at the left-hand side of this current segment, theta 1 is this lead angle between the direction of the current and the direction to that point P. And then, if I'm looking at the other end of this wire segment, theta 2 is the angle between the direction of the current and the direction back to point P. So those are my theta 1s and theta 2 respectively. As we continue this, we have mu naught, which is 4 pi times 10 to the minus 7. We have the current, which is 20 amps. We have 4 pi. We have R. R is the shortest distance, the perpendicular distance to the line of action of this current. So since this current is going along the x-axis like this, the shortest distance truly is this distance right here. Let me put that in blue. That is our R. So even if this were a skewed segment, it would still be that perpendicular distance from the point to the line of action of the current. So in this case, R is equal to 4 centimeters. So we have 0.04 meters for R. And then we have cosine theta 1. Now if I were to look at this 3, 4, 5 triangle here, then the cosine of theta 1 is the adjacent side over the hypotenuse. Hypotenuse is the 5 side, and the adjacent side is 3. So this cosine is 3/5. Now theta 2 is the supplementary angle of this angle right here, and that angle has a cosine of 3/5. So the supplementary cosine is going to be negative 3/5. So this is what we have. Now the 4 pi's cancel. And we have 2 times 10 to the minus 6 over 4 times 10 to the minus 2. 3/5 minus a negative 3/5 is a positive 6/5. And if we were to calculate this out, what do we get? I get 6 times 10 to the minus 5 Tesla. Or if we want to be cute about it, we could write this as 60 microtesla. Direction, as we indicated, would be out of the page towards you by the right-hand rule. So that's our answer. 60 microtesla out of the page towards you.